In a previous demo, we looked at the emission spectrum from hydrogen atoms and saw how discrete emission lines were caused by electronic transitions. Atomic emission can be seen from larger atoms as well. Many atoms give off vibrant colors when their electrons are excited, though the transitions cannot be described as easily as in the hydrogen atom. A great example of this effect can be seen from a flame test. This is an experiment you might run in a high school classroom or in an introductory chemistry lab. This is normally done by first creating a solution of whatever your metal salt is. Here I have copper sulfate dissolved in water, and then dipping a scupula or a nichrome wire into that solution and holding it into the flame. You can see really clearly that this solution of copper creates a bright green color, which is characteristic for its atomic emission. It's even easier to see the bright green color with the lights in the lab turned off. As I hold the solution in the flame, the liquid starts to evaporate, carrying away some of the metal ions with it. Once they're in the flame, the metal ions are excited by the heat, and then the electrons, while they relax, give off this characteristic green light. Now, when we run this demo in person in big lecture halls, a Bunsen burner doesn't work really well for people sitting in the back of class. So we try to do this with a little bit more bang involved, and we do that by heating the metal salt up using the combustion of hydrogen in a balloon. Here I'm adding copper salt to a balloon. And here I'm filling that balloon with hydrogen gas, which is highly combustible. To set it off, I use a candle at the end of a long stick that I light and hold underneath the balloon to set off the combustion reaction. That solitary green fireball looks great, but let's take a look at some other metal salts, all firing off one after another. This demo is called the Rainbow Balloon Demo, because each of these different metal salts gives off a slightly different color, creating a rainbow. Okay, and for this next iteration of the demo, I've got a series of balloons filled with metal salts attached to a remote ignition system. This remote ignition system runs a match to something connected with nitrocellulose underneath the balloon that will set it off. And what we're going to do is set these off in rapid series so we get something closer to a true rainbow than we would just setting the balloons off one by one with a candle. Watching this back in slow motion, we see potassium go off first with a lilac flame, then it's followed by lithium with a red flame, strontium, orange red, barium green, and copper blue green. And one last time,